Hi, I'm Ike Ellis, and now we're going to talk about what you should do now that you've successfully migrated your on-premise SQL database into Azure SQL database. So you did it. You migrated it. Now what? Well, the work has just begun, unfortunately, because the world has changed. You used to have an on-premise thing that you had total control of, and now you have something completely different that you have a lot of control of, but you've lost a little bit of control. So we need to talk about how that world has changed for you and what you should do about it. The first thing, and this is not exciting, this is not super great, but you've got to do this work. You need to work on governance. Governance is commonly defined as a set of policies, roles, responsibilities, and process. Nobody ever gets excited about the word process, but it controls this important business system or systems and how the various teams work together to achieve a set of goals. So one of those things in governance, and you know I'm going to say this, is security breaches. You now have a cloud resource. Hopefully you did everything right and it's totally secure. But you need to ask yourself some hard questions. Have you done your threat modeling? Who handles security breaches? What will be your response? Who is responsible? Here's a document that Microsoft will give you some helpful hints on governing security breaches. You also need to consider governance will span the life cycle of your Azure resources through the following major stages: migration, security, protection, monitor, configuration, and then finally governance as it relates to policy and cost management. I've added some helpful links here that might walk you through what your options are in these areas. But let's talk about management. Your management tasks have changed a little bit. Let's just pick one randomly. How about performance tuning? When you were on-premise, you were performance tuning using SQL Profiler. Now you have access to that in a VM, but you don't have that in Azure SQL Database or Managed Instance or Hyperscale. So you need to ask yourself, what am I going to do when I have performance problems? And even in a VM, where you might be used to like going into the ESX server or going into the SAN operating system and looking at certain numbers, you can't do that anymore. So you need to say, okay, if I have performance issues, what tools are available to me and how will I implement them? Some of your management tasks can be performed and automated in the Azure VM portal. You can create a VM image and put that in the portal, and it will help you. You can do a couple other things that will help you control licensing costs and help you reduce costs. So one tool that you can install in a VM is the IaaS agent extension for SQL Server. There's a link here. This extension will help you automate your backups, automate patching, and integrate with Azure Key Vault, all tasks that you're going to eventually want to be able to do. You have a couple of tools available to you for cost optimization: Azure Advisor, Azure Cost Management and Billing, and Azure Budgets. All three of those can help tell you where you're spending money and alert you if you're going over your budgeted account amounts. So cost optimization, by the way, it is very easy to spend money in Azure. And particularly, you might be empowered to just create Azure resources. And so you're in there and you're like, oh, I want to play with Azure Synapse, or I want to take a look at Databricks, or I want to look at Azure Data Factory. And you're adding things and adding things and adding things. And it's very easy to lose track of cost. So the unfortunate side of this is the CFO will not lose track of costs. Someone's going to get that bill, and that bill can surprise you. I had a customer get surprised with a monthly $12,000 bill related to Cosmos DB. That resulted that they didn't even know they were using Cosmos DB. So that resulted in an all-hands meeting for the IT department to answer for who did that, why did it get so big, and what can they do to reduce those costs. I'm not saying that $12,000 a month is a lot. I'm just saying when it's unexpected and it blows your budget out, people tend to notice it. So It's a really good idea for you to be thinking about costs right at the beginning and consider how you're going to manage it and handle it. Okay, here's a couple of things unrelated to governance. First off, once you complete your migration, it's an excellent idea to rebuild all your indexes. A lot has changed. Your disks have changed, your processors have changed, your memory has changed, and your indexes need to be rebuilt anyway, probably. And when you rebuild them, you also will rebuild your statistics. So you might want to rebuild these too, particularly on stats that aren't associated with indexing. So when you rebuild your indexing, your stats get rebuilt automatically, right? So that'll take care of that. Rebuilding the statistics that don't have indexing will also be helpful. What you're trying to do is get really good, clean, brand new execution plans, particularly if you've migrated to Azure SQL database or managed instance. You might be running on a whole new version of SQL. So getting the optimizer going and flowing and thinking about your data and making good decisions is a really good idea. Pay attention to your query store. Pay attention to the query plans that are getting chosen. You are going to need to know what the optimizer is choosing to do for the next few weeks so that you don't get surprised. You need to create a business continuity and disaster recovery plan. So your old plan that you had on premise has changed now that you're in Azure. So you need to revisit components of that plan. For instance, you might need to rewrite RTO and RPO. RTO is restore time objective, and RPO is restore point objective. So restore time objective is how long should it take you to complete a restore in the event of a disaster? Is it 10 minutes? Is it 10 hours? Is it 3 days? We need to know what the RTO is. That is decided not by you, but by the business. But the business might not have all the information related to Azure. So it's your responsibility to talk about what you've done in Azure and then allow the business to make a good RTO decision. RPO is restore point objective. That is how much data loss is acceptable to the organization. Is it 5 minutes? Is it an hour? Is it a day? Meaning if something goes down, when you restore it all back, how much data should be there, right? You might need to redefine that now that you're in Azure. You need to test your HADR plan, your high availability disaster recovery plan. On VMs, there is no high availability disaster recovery unless you build it. So do you need to build an AG? We have a lab that you can run through during this class if you'd like practice building an AG in Azure and failing over in Azure, where you can emulate what it would be like to have an AG in between on-premise and Azure. Are you using availability sets and availability zones? We talked about that in video 3. What is your backup and restore strategy? That's different than your RTO and RPO. It's just simple things like, where are your backups? How do you back up? How do you restore? How do you make a copy of the database? How do you stand up new environments? How do you stand up dev and stage and test? What's your long-term retention policy? Are you storing monthly backups for a year, yearly backups for 5 years? Now, we talked about that with Azure SQL database, but you still need to identify what that strategy is going to be with a VM, right? No matter where you put your database, you need to figure out what your backup and LTR strategies are. Are you testing it? It's really important that you test this strategy as regularly as you can. You may need extra training. You probably do. You need a lot more than just this workshop. There's a lot to learn about Azure and a lot to learn about all the different products that's now at your disposal. The cloud makes it so easy to just bring up a new project, play with it, look at it, do a tutorial, do a test project, create a POC, take advantage of all the different things that you can learn and grow your career accordingly. My company, Soliance, has made a lot of Microsoft Cloud workshops that Microsoft hosts, And I'm very proud of those. I'm going to show you one of them as part of a lab that we wrote in just a little bit. So we're very lucky. And I hope you click this link and check those out. We need to take about a look at security. There's a vulnerability assessment. It's a service that will let you discover, track, and help you remediate potential database vulnerabilities. Advanced threat protection will do the SQL injection detection and alert you. I think it's like $15 a month, but I'm not positive. And then there's a document for advanced data security for SQL servers that you should take a look at. Your virtual machine probably needs to have anti-malware installed. You should also take a look at Azure Security Center and use it to identify VMs that have public endpoints. You should put your security officers on your cloud offering to make sure that there's nothing exposed. It's really easy to make a mistake in Azure and expose something to the internet with a bad password. So you should, if you don't have an internal team looking at that, you should hire consultants who will do that for you and give you a report on the things that you need to lock down or at least look at. Remote desktop is a big entry point for attackers. Just in time allows us to deny all remote access until an administrator actually needs it. So there's a link to just-in-time in here. You can go into the Azure Control Panel and enable just-in-time, go into RDP, do whatever you need to do to the VM, and then shut down access again. And that will go a long way to closing a well-known vulnerability. Windows Firewall, enable it, use it, love it. You've got a VM. If that VM particularly has a public endpoint, you really need firewall. You're going to have an Azure firewall already, but you need to put Windows Firewall on all the VMs too. So just try to keep them as secure as you possibly can. We have great auditing mechanisms. One in particular in Azure is called Azure Log Analytics. Azure Log Analytics will suck all your logs into one place, which is really important because remember with Azure, you can have hundreds of products all over the place. And all of those products are logging. And you're going to kind of take all those logs and feed them into Log Analytics. And then you can query them with Custo. So you can say, oh, an event happened at 7:32 p.m. Tell me what event that was. I think it affected these services. Show me what happened here. And it's not just good for security, but it's really good for troubleshooting and for understanding performance and performance tuning and all sorts of use cases for this. So I would be a little careful with log analytics. It can get expensive. So just maybe be a little bit more pragmatic about how you use it, because I'd hate to have you get stuck with a really big bill. Okay. You could snapshot an Azure VM just like you can snapshot any VM. So once you get migrated and you're in production, anytime you're going to patch it or upgrade that VM or manage that VM in any way, take a snapshot of it so that you've got a rollback in case something goes wrong and you can go back and fix it, right? Here's something to consider: data virtualization. So remember when we had a great big SQL database and we said it's much better to have a bunch of small things in the cloud because then we can performance tune them a little more effectively? Well, one way that we can do that is through data virtualization. Data analytics platforms like data lakes have been using data virtualization for many years now, but we're just starting to see the benefit of doing this in transactional systems also. So remember earlier we said if you have blobs in a big SQL database, move them out to Azure Blob Storage and then put a pointer to those blobs in your original database, and it will shrink the database up. Well, you could do the same thing with tables that you're no longer using. So let's say that you have tables where the data might be interesting, but they are clogging up the works on your high-load transactional system. You could move those tables out to a Parquet file. If you are interested in this process, come to my session on Saturday and I'll talk more about this and I'll show it to you. But Parquet files are not like CSV files, but they are file-based. Remember the benefit of Azure Blob Storage, that you only pay for storage and you don't pay for compute? I mentioned that in one of the first videos. Well, you can take a cold table, a table you don't really use, you can move it to a Parquet file, you can store it in either Azure Blob Storage or Azure Data Lake Storage Gen 2. It's priced a little different, but fundamentally they're the same thing. You will shrink the size of your big SQL database, and then you can create a create table statement over the Parquet file. That create table statement will define the schema of the data that's in that file. So what that means is the schema stays inside the SQL database, but the data moves to a file. This is a legitimate way of making your database smaller and moving that data to cheaper storage. So your hot data stays in the big SQL database and your cold data is file-based with a table structure metadata over it. Guess what? You can select star from both the table in SQL and from the table in either Azure Blob Storage or Azure Data Lake Store. And that means that the data is accessible to you even if it's quite a bit slower. So this is an interesting use case. There are ways to implement this. It is a little bit complicated right now. Hopefully in the future this gets better and better. But what the result will be is that you'll have a smaller, faster, cheaper SQL database that's ready to move to PaaS offerings out of the VM and into Azure SQL Database or Cosmos DB or Managed Instance. Perfect, right? Okay. Now, another thing to consider is platform modernization. You probably have a lot of old components that have been sitting out there that your company has been using for 10 or 15 years that probably needs to get modernized and ideally moved over to a PaaS offering and not an IaaS offering. Now, one of those things could be SQL Server Analysis Services, or SaaS. SQL Server Analysis Services has a PaaS offering equivalent in Azure called Azure Analysis Services. It only supports a tabular model. It does not support multidimensional. Not all data sources are available that you have in SaaS. Not all DAX formulas are supported, and there are limitations with direct queries and tabular models. But it's easy to migrate. Believe it or not, you can back up an on-premise SaaS tabular model and restore it into Azure Analysis Services. Or you can go into your project in Visual Studio and just redeploy it into Azure Analysis Services and reprocess. You might need to consider the networking setup between Azure Analysis Services and your on-premise data sources. Remember, when you reprocess your cubes, Analysis Services goes down through your network, grabs the data out of the SQL database or wherever the sources are, and brings it back into the cubes. If you have bad network connectivity, that process is going to take a lot longer. So remember, Express Route is still the key to make this faster and better for you. Another old component that you might need to modernize is SQL Server Integration Services, or SSIS. This old faithful guy has been around for a long time. It used to be called DTS. Probably took you a long time to migrate it from DTS to SSIS, and you're concerned about what you're going to have to do with it now. Well, you can still keep it in a VM if you'd like. That is still, you can just keep it in the VM and keep running it. If you have ExpressRoute or a VPN, it will likely connect to all your old data sources on premise, and it will likely, most of these packages will probably run just fine. But if you would like to modernize them to a PaaS service, you can use them in Azure Data Factory. Now, Azure Data Factory can use SSIS packages in two ways. The first thing you can do is you could just convert it to ADF. That is not recommended. SSIS packages do not convert to ADF very easily. They take a lot of work to do that. A second thing you can do is you can use the ADF SQL Server Integration Services integration runtime, and you can run the SSIS package inside ADF. Now, the SSIS package will likely still need to be modified because there are some nuances and kind of weird things that go in there, but you can run it inside ADF, and it won't be as disruptive as just converting the whole package to Azure Data Factory, right? Remember Data Migration Assistant? I showed you that demo in a previous video. DMA has an SSIS conversion utility, so it will assess your SSIS packages and tell you what's not compatible. So this can help you, and it can tell you the things that you need to change in order to make this thing ready to go to a PaaS offering. That's amazing. So try that out and see what it does. You can also migrate the full SSIS catalog. You can migrate it to the VM, and you can actually deploy SSIS into the SSIS DB in Azure SQL Database Managed Instance. So now you can run it with an MI SQL agent job, and you can run SSIS right into MI. So that would be a terrific place to make SSIS a PaaS service. Pardon me. So the next component you might want to modernize is SSRS, SQL Server Reporting Services. You love it, I love it, but what do we do with it? Well, we can keep it in a VM for sure, or we can deploy new reports to Power BI. Now, it's important to note that your existing SSRS reports cannot be deployed to Power BI by themselves. So we know that SQL Server Reporting Services stores the reports in an RDL format. That stands for Report Definition Language. So Microsoft wrote an RDL migration tool, and here's the link in GitHub to that tool. That migration tool is meant to take an SSRS report and convert it over so that it's deployable inside Power BI. It's called the paginated report, a Power BI paginated report. The tool will only migrate RDL files, but the following are not supported: shared data sources, shared data sets, image files, KPIs, mobile reports, report models, and report parts. So any reports that have any of those things cannot be migrated. But if they don't have those things, they are a good candidate for migration. So try the tool out. The problem with Power BI paginated reports is that it really only works with Power BI Premium. Although, you know what, I need to check myself. I think there's some new information lately that means it might work in other places too, but I'm not positive, so verify that. But the point is, it used to be very expensive to host those. So just be aware that the pricing is pretty strong there. Okay, remember here from the beginning of our lecture where we had this great big huge database, and we had all these different things that were using it, and we had to accommodate all of these different things, and how are we going to migrate all of them? And we had to account for all of this. Hopefully you're feeling a little more calm about migrating this huge monstrosity, and you've been thinking about all the things that are going to be affected here and making a list. But we didn't quite achieve our goal, did we? Remember, our goal originally was that we would take this big, huge database that had all the tight coupling, and we would turn it into this, where we had much smaller databases, and we had individual apps that were only connecting to their store, and we didn't have people tightly coupling this database. And remember, we wanted these small databases so one, we could move to a cloud PaaS offering, but two, so that we could change them, we could modify them and upgrade them, and not have this huge wide testing surface that was really, really affected by all this stuff, right? So this thing right here, we call this a legacy system. And I had heard a really good legacy system definition. You define a legacy system because whenever you change something, there's just way too much to test. And so people tend to not test it. So anything that's widely not tested is a legacy system that nobody wants to change because you don't know what's going to break. So how do we get from here to something cleaner and easier to understand, what do we do here, right? Well, if you come back here, let's take Excel. Remember the scenario where the CFO used Excel to hit the huge database, and then the CFO used that so that she could close the month out or the year out or something like that? Well, one thing we could do is we could take the data she's interested in and create a data pipeline like Azure Data Factory to extract the data every month and put it in a CSV so that we can run analytics from Excel. That actually won't take that much effort. And by extracting the data she wants and put it someplace so she can analyze it on an interval, we retain control over modifying the database because we can wrap tests around the data extraction. And that's the key point. When we write new functionality, we should always be thinking about how we can write automated tests around that new functionality so that it's in the future changeable. So if we look at like SSRS reports are hard to test, and they might be change locking this huge SQL database. So if we extract some data that SSRS wants to report on, and we put it in a data lake or a data mart or an analytical system, now we can test the data extraction because the report's not testable. And as long as the data extraction keeps running, now we can modify that database, right? So slowly and surely, by introducing tests to this environment, we can move from a situation like this over to a situation like this. Does that make sense? So, Ike is what you're thinking. Ike, that's much easier said than done. Please help me understand the problem and tell me how to solve it. Well, the main problem with legacy applications is that we have too many dependencies and there are not enough distinct decoupled layers in our applications and our systems. We call that bleeding layers, meaning the layers are bleeding into each other. This results in code that is unreadable, code that no one wants to change, where we repeatedly introduce the same bugs over and over again. Do you ever get that? You deploy something and your users say, you always break that. Like every time you deploy, you always break the same things, right? This is because of this big monolithic legacy system. Well, if you would like to learn how to break a monolith apart into smaller pieces, we do not have time in this course to teach you that, but I can show you how I learned it. I learned it from this guy, Michael Feathers. Michael Feathers wrote a book called Working Effectively with Legacy Code. The theme of this book is how to test big legacy monolithic data-bound applications. And he talks about a lot of effective techniques and strategies you can use to break out the monolith and put it under test. There's a link to his book down below. Michael Feathers is actually a really nice guy. You can call him, you can email him, and he'll respond. You can tweet at him, he'll respond. You can hire him, and he's not all that expensive. If you want Michael Feathers to come out and speak to your organization, he will do that for you. And you should try it. I've had him come out to customers of mine, and he's been terrific. One of his techniques he calls stinting or seam testing. So when you have these bleeding layers together, a seam is a place where you can alter behavior in your program without editing it in that place. So I know this sounds ridiculous, but imagine that you have that join between the membership table and the inventory table. And you're like, this thing is too tightly coupled and I don't know what to do here, right? Well, why not create, let's say that you're writing the membership part, right? And the inventory part of it keeps hitting your table, right? Why not create two membership tables? I know EFCOD wouldn't like it, but if you create two membership tables and you have your membership API and middle layer write to two tables, if you put the inventory app on one of those tables, you get to change the other one. And the other thing you've done is you've put a layer in between you and the inventory app to decouple it. That layer that you're putting in to decouple it is called stinting. So once you stint something, you separate the two things that are too tightly coupled so that you can wrap tests around both sides. So I'm not saying that I recommend that method. Maybe there are better methods, but I'm just giving you some ideas on how you can take a tightly coupled system and slowly start separating the coupling so that you can stint and put a layer in between them, and then wrap the two things in tests so that they're now individually changeable. If we do enough of this technique, we will eventually get to a place where we can take everything that membership cares about and put it in its own database and make sure that nothing but the membership app can touch that database. And once you see that you can do this, you are now beginning to see the power of a microservices architecture. So imagine that we've got a great big puzzle, and what we're doing is trying to take the puzzle pieces and separate them while leaving them in their original position. So that means that if the puzzle's this big, we're going to make the puzzle this big, where we can still see the picture, but the pieces are individually movable in and out. That's what we're trying to do when we build tests around a huge, big monolithic system. If we can separate the puzzle pieces out, we are creating individual components that can be upgraded, deployed separately. And now, potentially, you can take one of those puzzle pieces and move it to Azure SQL Database or Cosmos DB or another PaaS offering. Only convert that subset to PaaS. Good candidates for taking a puzzle piece out and getting it into PaaS are archival systems, identity and authentication systems, and notification systems. But there are other good candidates. I can't identify a good one for you. I'd have to know more about your system. By separating out a component out of a legacy application, you now can rewrite it. If you would like to change from a relational system to Cosmos or NoSQL, if you would like to rewrite it from C# to JavaScript or Node or TypeScript, you could only rewrite something once it's been decoupled and separated. Another key tenet of the microservices architecture is that we let the developers choose their data store, and we give them total control of the data store. That's going to change your world in Azure quite a bit, because you're going to have to stretch your expertise beyond just SQL systems and get to know all the other data stores that are potentially available to you, including Azure Search, Redis Cache, Azure Blob Storage, Azure Data Lake Store, maybe even learn some Synapse stuff. There's a lot to learn in the cloud. And particularly if the developers choose their own data store, they're doing this because they want to make sure that only their application touches the database and that all integration is done through Event Hub. So learning a little bit about Event Hub might be beneficial to you. You know, BI teams can consume Event Hub too. They might use the Kafka API because it might be more familiar to them. But if your membership application hits the membership database, and anytime there's a change there, it issues a change feed over to Event Hub, your analytics teams can use the Kafka API and pull those events off Event Hub to build their systems. That means no more ETL. That means they don't need access to the database either. I'm going to say something pretty controversial. Your analytic teams do not need to go into your transactional databases and pull data out. The more you let them into the database, the more you change lock that system. It is a bad practice to let them touch that system directly. Publish records and data through event hubs, and you will retain control over it. Allow them into your backend database systems, and you will lose control. And you'll be right back in a legacy system. So, what's a good boundary for separating out legacy systems into microservices? Well, think in terms of deployment. Which of these features would you like to be tested and deployed together? What I like to do is think about the smallest component you can that you are likely to test and deploy together, and that component is now a microservice. Keep the testing surface area small enough, but not too small. You don't want 4,000 microservices. You want, they're really called domains. Each domain has a set of microservices, but really the domain is the set that's getting deployed as a unit. How many domains do you want? About a dozen, maybe 20, maybe a little more. But I know organizations that have gone crazy with this and they have 1,000. That's way too small. It's way too much to go and manage 1,000 different databases that all have 1,000 different purposes, right? So try to keep your organizations in the 12 to 20 range. Seems like a good idea to me. Version them and think in terms of remediation. How are conflicts resolved? What do I mean by that? Well, let's say that I'm membership and over there is inventory, right? When inventory is angry that I changed the API or the JSON in the event hub, how do we remediate that conflict? You want to keep data access remediation about one level ahead of you. So what would be great is if the leader of the membership team and the leader of the inventory team had the same boss. If they had the same boss, the remediation is really easy. So always be thinking about how conflicts are resolved. If conflicts are easily resolved, maybe you can give that other team a little more access. If conflicts are not easily resolved, then give them the least amount of access you can and keep things super decoupled, because you're not going to have a great path to get that conflict remediated. Okay, the death of the DBA. You are now an Azure Data Architect. So we need to talk about your roles and responsibilities. We need to talk about your day-to-day life. And we need to talk about the rise of your career. Here are things you no longer need to do. You don't need to sweat about disk space. In PaaS, you don't. In VMs, you do. You don't need to worry about patch level and security patches. In PaaS. In VMs, you still will. Upgrade plans in PaaS you won't have to worry about. Care about what the ops guys are doing. Wonder if you're going to get a priority on the SAN. You don't have to fight over SAN disk space anymore, because Azure Blob Storage will take care of all that for you. You don't need to purchase hardware or argue about capital expenses. So there's a whole lot of things that you probably won't have to do once you get off VMs and you're in PaaS. Things that you absolutely have to do. You need to start following every blog and Twitter account for all the teams and products you're responsible for, because they move fast in the cloud. They upgrade, they release, they change. Even now, I bet there's things about this slide deck and the videos that I've made that are already out of date because things change so quick. So learn as much as you can about a wide variety of products. Interact with your developers. It is now your day to watch those developers and see what they're doing, because they're going to be more empowered to do more data-oriented things, and they're going to need your help. Decouple everything from your schema so you can normalize or denormalize as necessary, which means try to get the apps off hitting the tables directly. Decouple, decouple, decouple so that you can change. Remember, it's much easier to change small things than it is to change a great big large thing. So try to keep things small. Consider partitioning. Partitioning is a way to make a great big table, really a series of really small tables that are easier to modify, like defragment and maintain. Partitioning will also help you think in terms of horizontal scale, which is a very good practice to get in the cloud. Learn scripting, because your number of databases, well, they're about to explode. And so you're going to need to learn scripting so you can manage them collectively without having to do things one at a time. Your day-to-day life, you're going to be creating scripts for all sorts of manual activities. You might need to learn a little bit of terraforming. That's the scripting language we use to stand up environments in Azure. You can learn scripting and automation, create some frameworks to deploy dev and test environment. You might want to learn about Docker and Kubernetes, learn Python, watch your data models, watch your performance, predict some scale up and scale down. So you might want to be looking at things that you might want to turn the slider bar on to see if you're going to scale it up and scale it down. You need to watch your bill and your costs so you don't get yelled at. And then watch those developers, because those guys are going to have power to do a bunch of things. As you embrace the cloud, your career will rise and you will have a lot of future opportunities. No longer is knowledge about just SQL Server acceptable. You need to learn Cosmos and Couch and Redis Cache and all sorts of different things. Learn some NoSQL, learn about MPP and analytics, learn about data pipelining. If you learn these things and you become an Azure data architect, believe me when I tell you, you could double your income. I have colleagues that are well into the 200 a year mark because of how good they are in the cloud. As of 2020, these skills are in high demand and there are not enough people that know them well enough to support all the businesses that are moving to the cloud. And that's it. I hope you've enjoyed this class. Now on to the lab exercises. I hope you really enjoyed the labs that you're about to partake in. Thanks a lot, guys. It's been a pleasure having you. I hope you've enjoyed chatting with me and having all your questions answered. Thanks a ton.